Hello, good afternoon. My screen is visible.
Yes, sir.
Okay. I am audible also, right? So, good afternoon, everyone. So, today we are in the last week of this problem solving session. So, in this week also, I will take one extra session. So, where I will discuss about whole whole of things that what I am discussing problem and some other problem. And if you have any doubts, we can solve in the next last session, last 1 hour or 2 hours. So today's session mainly focus on that polymers that when we are doing the processing of the polymer, like when we want to make some mm, material from that polymers, like what you are using in the day-to-day life, and what problem we are facing like that. So related of that problem we are solving today. So before start, I am introduce about myself. Myself Probir Maiti. So I'm taking the course name is Introduction to Polymer Science, course instructor Professor Divakar Dhada. So earlier classes I am talking about that how we can process the polymer, like that there will be various type of instrument like compression molding, extrusion molding, injection molding, where we can mold our polymers to get a perfect shapes what we can use this polymer. So during this compression molding and injection molding, so when we are molding that our polymer sample, so there that when we apply the shear stress, so the viscosity arises into the polymer sample. So this viscosity arises into the polymer sample that depends on the behavior of viscosity depend on the shear when we can plot it shear stress versus shear strain rate. So from this plot, if this plot are like straight line, like shear increasing shear stress, your shear strain rate also increase, so that will follow that Newtonian type of polymers. And when they are non-Newtonian, so maybe some polymer will be like that with increasing shear stress, that shear strain rate with increasing shear strain rate your shear stress will be decreased, like pseudoplastic. And some other polymers like with increasing shear strain rate your shear stress will be increased. So they are non-Newtonian type of fluid. There will be another type of fluid. So after some shear stress, we are getting a Newtonian type of behaviors. So that we call like Bingham plastic. So here for this that polymers melt or viscosity of the polymer solutions, we can identify by this following equation, like shear stress versus shear strain rate. So for a like first question was like that, for a Newtonian type of polymer melt, shear stress is proportional to what? Shear strain rate, yield strain, or maximum strain. So which should be correct answer? So we are plotting shear stress versus shear strain rate. So this should be our correct answer, not that only shear strain, not the correct answer. So if you saw the Newtonian law of viscosity, if you follow this equation, so where the shear stress is given by this equation and shear strain rate given by this equation. So here that dBx by dy is mainly that strain rate, not only shear strain. So if they are follow that straight line behavior like laminar type of flow, then we call it say Newtonian type of behavior or Newtonian type of fluids. We can call it. Next similar question like identify the behavior of the plastic sample presented in the following plot. So here the shear stress versus shear rate it will be given, and there they given that plot. So what this plot suggests that this is a Newtonian type of fluid, pseudoplastics, shear thickening, or Bingham type of plastics. Which one should be correct answer? I am audible, right? Hello, hello.
Yes, sir, audible.
Yeah. So you can tell na this answer the which one is belongs to. So it should not be the Newtonian one because Newtonian it should be the straight line. So plastic means after shear rate that it will be like plastic behavior like that your shear stress will be decreases, and if it will be shear thickening, so after shear rate it will be increase that your shear stress, so that will be shear thickening, and Bingham will be started like after some shear stress, so it will be follow the Newtonian type behavior. So here the correct answer will be pseudoplastic, right?
Op-
Hello, anything?
Option D.
Hello, someone want to say something?
Option
So option B is the right answer, pseudoplastic.
of models, sir.
Hello. So like if you talk about the Newtonian fluid, it's that it should be straight line. The pseudoplastic means it decreases with increasing the shear stress will be decreases with the shear rate. So here the your curve will be like little down. So that will suggest that with increasing your shear rate, your shear stress will be decreasing. So that behavior is the pseudoplastic behavior. So now the next question is that the optical property that relates the reduction of the resolution is that yes, gloss or birefringence or clarity. Which one should be the right answer? So the clarity is the
Clarity.
ability to yeah, ability the sample to transmit the fine details of an object viewed through it. So it should be reduction in resolution. So if the clarity is good, then that your resolution is good. We can distinguish between the two things. So resolution means that when you zoom out anything, like you zoom this one, so you can distinguish these two differently, and you can clearly see these two. So that will tell us about that how much resolution that one. So better resolution means that better you get that small one, you can get better resoluted picture, a better resoluted object you can. So that will give your clarity. If clarity is good, your resolution should be good. And reduction of resolution, your clarity will be changed. Now, and next question is a blend of polymer A and polymer B is found to be Tg 140 degrees centigrade and 112 degrees centigrade. What can we conclude about the miscibility between the two polymer Tg of polymer A and polymer B 150 and 100 degrees centigrade? So like that, when they have done the DSC, like you done the DSC of the polymer sample, the dynamic scanning calorimetry, where we can get that Tg of the polymer sample. So in Tg, so they are doing that simple polymer A Tg, so they are getting that polymer A Tg around 150 degrees centigrade, like that. And polymer B, which have Tg around 100 degrees centigrade, maybe comes here 100 degrees centigrade. But when they have done that blend, so they are making that blend of polymer A and blend of polymer B. So then they are getting the TGH around 112, maybe a little bit here, and also another TG around 140 degrees centigrade, like that. So they are getting two TG. So if the polymer is completely miscible to each other, like a polymer such a way that the two polymer are completely miscible, for that cases we are getting 1 TG for that blend, miscible blend. But when we are getting 2 TG in a polymer sample, so that will suggest that polymers are not miscible to each other. Then you talk about like if they are completely not miscible, then their TG is not changed, like similar to like their their own TG, like 150 or 100. And if their TG is slightly different after blend, so that will suggest that they are miscible little bit but not completely miscible. So that will suggest that. So if they are completely miscible, then we are getting only single TG. Is if they are completely immiscible, then we are getting the TG of their own, like 150 and 100. But if they are partially miscible, then we are getting TG in between them, not 150, not 100. So it should be in between them. So that will suggest that they are partially miscible, not completely miscible, or not completely immiscible. So your C will be your correct answer. So these two polymers are partially miscible. Now the next question, you have to calculate the glass transition temperature completely miscible. So here that they have write already that the polymer is the completely miscible polymer. So if we are talking about completely miscible polymer blend, so then we are getting a TG of the polymer only single TG. So from here the blend have that single TG, not double TG. So that you can, that earlier classes also we are getting the equation. So TG of the blend, so if the TG of the blend equal to the weight fraction of A polymer divided by its TG, so TG of A, you can write is the blend TG plus weight fraction of B divided by its TG of the blend, TG of B. So now the weight fraction is given that for A is 30%, so it should be 30 divided by 100, so it will be coming 0.3, right? So A is given 30% and B is given 78%. So weight fraction will be, so plus 0.7. Now TG of A, so TG of A is given 45 degrees centigrade. So when we are putting this in that, this is the Fox equation. So we are putting in this equation, so always we
318
have,
Kelvin.
yeah, always put into Kelvin. So like, so 45 means how many Kelvin? 45 plus
318,
273, so it will be 318 Kelvin
248, 348.
and it will be 348. Yes. So now we can calculate it. Then you will get the TG in that Kelvin scale. So then again we have to calculate in degree centigrade. So here that you write the Tg in degree centigrade. So you can calculate it. So 0.3, how much it's coming? If you calculate it. So it will coming around Tg. So if you calculate it, it's coming around Tg around 338, right? So Tg of the blend, it's coming around 338 point something, like that. So if you then you have to minus it by that Kelvin scale. So minus 273. So after that you are getting the Tg of that polymers. So it is coming 63.6 degree centigrade. 63, 65. It is coming around 65 degree centigrade, right?
65 degree.
So now the next question is that this that easy question, it will be generally you get also in that GATE exam or somewhere if you giving in the polymer. So this TG and this that plot of this Newtonian fluid Bingham plastics. So every alternative years this question coming in GATE. So for a polymer sample, elastic behavior is demonstrated at high shear rate at high temperature, low shear rate at high temperature, high shear rate at low temperature, and low shear rate at low temperature. So how the polymer is behave like that, elastic behavior. So polymer elastic behavior means so they are not, so elastic behavior means so when you plot stress versus strain, so it will be perfectly straight line. So they are not changing that strain rate that much with increasing the shear stress. So it will be coming after taking out you taking out your load. So it will be elastic behavior. So it will be you load it, so it will be stress, but after taking out your load, so it will be coming back its original position. That will call that elastic behavior. So that elastic behavior is given when you have that at the lower temperature and you have that you need that so at low temperature, so you need high shear rate also there. So for high shear rate and low temperature, polymer chains do not have enough mobility. So if you go to the lower temperature, so the polymers have not, so like we, when we are increasing the temperature, the polymers become mobile. Like they have that increase the temperature, they have crossed that TG temperature and that polymers become mobile and they can move. When you stress it, they can move. But if they are in the lower temperature, so that polymers are not that much mobile that it can move easily. So you need much more stress to move it. So that will suggest that its shear rate will be uh, that you need that higher shear rate to move this polymer at lower temperature. So for the elastic behavior, so you need that higher shear rate and lower temperature. So that will diminish your that polymer mobility. That polymer chains are not movable to each other. So and if they are not movable, so they are maximum in the elastic state, not in that rubbery or plastic state. Yes, yes. Hello.
But hello,
Hi, yeah.
uh, actually, what is the difference in between the plasticity and viscosity of a polymer?
So
So
plastic.
sorry, elasticity also. So the
So when we are coming that viscosity, the plasticity means the polymers have that. Uh, if we first the elasticity, so elasticity will be like that. So if we apply the load, so it will be come back to its original position. But when there will be plastic deformation like that, so it will be come back to its original position, but it will take some time. So that will be the plastic. But when you have that like the polymer have the viscous deformation, so it will be some permanent changes into the polymer sample. So it will be never be come back its original position when they have that polymer have that some viscous property. So and that polymers that we are generally used that semi-crystalline polymer. So they have like that viscous property. So if you have stress it after certain load, so it will be like that. So it will be not come back to its original position. So that will suggest that is that viscous deformation. So plastic
so
deformation, yeah. Elastic deformation means it's that instant, and plastic deformation means that the time dependent. And if you go to the viscous deformation, so it will be never be come back to its original position.
so in plasticity also, while we deform a polymer through force, it can regain the original shape, but
Hmm.
it follow a hysteresis like loop.
Yeah. So it will be come back and it will take little time. Yeah.
In
But
elasticity, in which path it get deformed, it
it will
go
straight
to its
line. So it will be coming
so-
when you load it. So it will be coming originally come back. It should be maybe that loop. If you go to the loop wise, maybe that loop will be that historic loop, but that loop width will be very low for that elastic material. Maybe I need to check that one. But you
so
remember it?
um,
Yeah. Yes.
plasticity property of a polymer lie in between elasticity and viscosity.
Yes. Plasticity is in between them. Yeah. Right.
Thank you, sir.
Okay. Now the next question is the which of the following properties get improved over base polymer on addition of nanofiller. So when you are adding nanofiller means that there will be enough polymer. So if you want to make that final
Barrier
products,
properties.
yeah. Um, so we want to make the final product. So you want to make the strengthen of that polymer. Like polymers have that only that polymer sample. So there will be nothing is there. So to make the strengthen of this polymer sample. So you need some fillering agent or inorganic agent to strengthen the polymers. So there will be various type of additives we can add into the polymers to strengthen the polymers or make you can add that coloring sample to make good color property look it better like that. So when that nanofiller is coming, so nanofillers is generally type inorganic type of filler. You can add silica or something there. So when you add that nanofiller, so what will happen? So that which of the following properties get improved base polymer on the addition of nanofillers. So that properties like heat distortion, temperature, barrier property, ductility and transparency. So ductility means that how much ductile. Ductile means how much can load it can absorb. So when we add the nanofillers, so the polymer are not that much soft or ductile. So with increasing the nanofiller, the ductility reduces. The transparency, so transparency also reduces with increasing that nanofillers, because that when we add the nanofillers, so nanofiller have that inorganic type of materials which comes into the polymer surface, so that transparency is loses. So we can increase that its heat distortion, temperature, barrier properties like that. Heat distortion temperature means how much temperature it needed to distort that polymer sample. So if you add the filler, so now due to this filler aggregation, because that inorganic particle aggregation will be much more better as compared to that polymer. So you need higher temperature to distort them. So this two will be right answer, like barrier properties and heat distortion temperature with increasing the nanofiller. Now, when we are talking about the polymer viscosity, so there will be a equation that which can give that viscosity behavior. The damping ability of the polymer sample measured by the storage modulus, and G prime is the storage modulus and G double prime is that viscous modulus, and the ratio between that viscous modulus and that storage modulus is that damping ability of that polymer. So damping ability means that if that loss modulus will be more high, so the damping property of that polymers will be much more better. So polymer need to much more viscous property, then that polymer will be, have that better damping property.
D, option D.
Yeah. So option D is the right answer. Now the any that chlorinated compound that brominated aromatics work as a fire retardant. So how it will be work? Forming an insulating char on the substrate, interfering with the chemical reactions that maintain the fire, promote to spread the flame, releasing water at high temperatures, which inhibits that combustion, and all of three. So this is not the right answer, releasing water. The forming of chars also not that right for that brominated compound. So it will be doing only that chemical reaction, and which will be promote to reduce that fire spread. So the B will be right answer. So it will do the chemical reactions which will lead to reduce that flame. Now that same type of that question, shear stress versus shear strain rate, shear rate. So here we have to tell that how it will be behave. Like it will be behave Newtonian,
Brigham
pseudoplastics.
plastic.
So it will be Bingham plastic. So Bingham plastic is uh, that the material, but that after some stress, shear stress, so it will behave like a Newtonian type of behavior. So it will be Bingham plastic. So up to this, do you have any problem? So today's class is very short. So you have any doubts regarding whole classes or anything? So that doubt we can discuss in that next classes. So if you have doubts, so you can send me or you can tell here also. Do you have any doubt, Preeti? Someone
No, sir.
like no, not today's classes. That whole week or whole lecture of share classes anywhere or any problem you are not find out yet.
In week three, some problems, little doubts were there, sir. Again, I'm going to solve that. I'll practice that. Remaining every sessions were good and it was interactive, sir. Very good information from you. And the classes were too good, sir.
Okay, so week three.
It helped a lot to for solving the assignment questions and all. Little week three, sir. Many problematic will be there now. I think week three or week two, some more problematic questions were there. In that
Okay,
some value instead of instead of time we have taken temperature and we have salt, so we have lost marks there. That little bit confusions happened. Rather than that, it was very good, sir, overall.
okay. So in that like doubt clearing session, so you'll follow that overall session, and we
Hmm.
generally focused these 2 weeks, week two and week three, right?
Yes, sir. More problematic were there around week two and week three. And regarding kinetic sense also, little it is tougher comparative all modules. So we felt
Okay,
very difficulty in those weeks comparatively.
okay. And last 3 4 weeks it will be very easy. Like it will be
Yeah, sir, it was too good, and the problems were also very easy to identify
yeah,
and solve.
answer it.
But
Yeah.
2 and 3 week, little confused, sir. Mm.
Yeah, that the
Um,
kinetics part is little
yes, sir.
little bit
Mm.
it's difficult also. So it will be when you have to study
Mm.
little much more there.
Yes, sir.
So when you have that exam, like final exam.
Sir, coming Saturday, 21st September.
Okay. So you give your exam in your nearest center like that.
Yeah, we have in Bangalore only, sir. Was the center we have chosen that Bangalore only we have. Mm.
Okay. So I have classes. So I have taken that hold out clearing classes in that Tuesday or something. I do not remember the date.
Ah,
Maybe you get the mail maybe after before that. So we
sure,
generally
sir.
focus that week two and week three, and
Sure,
also
sir.
we focused
Little
all of
problematic,
this.
sir.
Yes.
Because theory it is easy to
Mm.
problematic session you take, sir. One overall for all, so it will be easy for us for the examination part.
Also week two and week three year that this what called the your assignment you already solved that, no?
Yes, sir. I have already solved.
So if when I also taking some question from there that assignment, so that will also help
Yes, sir.
you.
That will help us. Sure, sir.
Okay. So we'll meet in the next classes, maybe Monday or Tuesday.
Sure, sir.
Best of luck for your exam also.
Thank you so much, sir.
Okay, thank you. So thank you. Bye. So we'll meet in the next week.